And welcome to the fifth lesson in Module 3, where we are graphing quadratic functions from factored form. So let's jump right in. You should have your unbounded student version of this lesson in front of you and follow along. Again, pause the video where you can to try something on your own first before you then see me. So these opening exercises are actually a review from previous units, so I would encourage you right now actually to pause the video and try A and B on your own. Okay, so let's do these here. Letter A asks us to solve this equation. It's already equal to 0, so we can go ahead and try and factor this. I'll notice over here there's no GCF or anything to factor. There is a 1 for our lead coefficient, so we can go ahead and just do that product sum thing. We're looking for two numbers that multiply to negative 40 and add to make 6. And those two numbers here would be, actually I'll do it over here. Positive 10 and negative 4. And now we have a product of two things and equal to 0. So we can go ahead and set each one of those two factors equal to 0 and solve. And so we get x equals negative 10 and get x equals 4 as our two solutions there. Okay, so let's look at this next one. Okay, now this one is not equal to 0, so we'll need to do that. I'm going to go ahead and subtract x squared over, add x over here as well, and add that 32 over here too as well. So we end up with then x squared plus 12x plus 32, and it's equal now to 0. So again, I'm looking for two numbers because our lead coefficient's 1, no GCF. Looking for two numbers that multiply to 32 and add to make 12. So what would that be? Well, it would be 8 plus 8 plus 4. And again, if I set each of these equal to 0, then we get x equals negative 8 and x equals negative 4 as our two solutions there. Okay. Let's continue on. So now let's take a look at what we're actually looking to study in this lesson. So consider the equation y equals x squared plus 6x minus 40. Given this quadratic equation, can you find the points where the graph crosses the x-axis? Well, the x-axis, right? If you think about the coordinate plane, this is the x-axis, right? What do we know about any point on the x-axis? Any point on the x-axis will always have a y-coordinate of what? 0. So we can set y equal to 0 here. And solve for x to find those coordinates. Okay, so factor it. And again, this is from before, right? Yep. And so it's just going to be the x plus 10, x minus 4. So in other words, x equals negative 10 and x equals 4. Those are our x-intercepts. Okay. How can we write a corresponding quadratic equation if we are given a pair of roots? Well, if we know the roots, if we know the zeros, in other words, or the x-intercepts, we can take those, we can rewrite factors that yield the given roots as solutions. Okay, we may have to do a little bit more work than just that, but at least we could write a quadratic equation that would have those same roots. Okay, but typically we would actually need a third question, a third point to help us get the exact graph. In the last lesson, we learned about the symmetrical nature of the graph of a quadratic function. How can we use that information to find the vertex for the graph? So we know that since we have the roots, so find the midpoint of the roots to find the x-coordinate of the vertex. Okay, that's using symmetry, right? I mean, we think about, let's say we had a graph that opened upwards, right? So there's our vertex. Sorry, not the vertex. We don't want to look at that just yet. Here's a 0, here's a 0. So halfway between, that would be the x-coordinate for our vertex. And the same would be true if it was, a parabola that looks like this too. Okay? Part D. How can we find the y-intercept where the graph crosses the y-axis and where x is 0? And that's the giveaway right there. We know that the y-axis, any point on the y-axis, the x-coordinates are all 0. So we just can plug 0 in for x and solve for y. We will only ever have one y-intercept. What else can we say about the graph based on our knowledge of the symmetrical nature of the graph of a quadratic function? Can we determine the coordinates of any other points? So, the answer is yes. Okay, we can use symmetry to find additional points on the opposite side, or the side of the graph opposite the axis of symmetry. And in so many words here, what we're really just trying to say is that, if you find that axis of symmetry, let's say it's right here, and like that, there's our vertex. If you find a point over here, you can go the same exact distance over here, and you'll have another point as well in the exact same y value, kind of thing. If you have a point right here, and you're this distance away, you go the same distance away over here, and you have another from that axis of symmetry. Okay, you'd have another point in the exact same location. So you can use the symmetry to help you. So let's go ahead and plot the points. I'm just going to do it right here because I don't have graph paper handy, so we'll just do it right here. Okay. Actually, I might be able to change it to grid lines. There we go, in the back there. We can just do it over there. Okay, so let's see here. We were trying to graph x squared plus 6x minus 40. Okay, so let's do that over here. Okay, so let's see. Okay. We have the x-intercepts at -10 and 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4. 1, 2, 3, 4. And the y-intercept, we didn't calculate it, but if we plug 0 in here, we're going to get -40 as a y-intercept. Woof. Goodness gracious. We have to count by I'm going to count by 5s here. So 5, 10, 15, 20. This would be -5, -10, so on and so forth. So 5, 10, 15, 20, 25, 30, 35, 40. So we'll see there's -40 right there. Okay. And then by symmetry, well, let's see if we can find that axis symmetry. So if this is -10 right here, and this is 4, it means this distance is 14. This whole distance here is 14. So I'm going to go half of that, which would be 7. 1, 2, 3, 4, 5, 6, 7. So there's the axis of symmetry right here. And so I'm 3 away here, so I'll go 3 in this direction over here, and I should have a point right there. And my vertex is going to be somewhere along here. Again, it's going to be at -3, so I'll plug -3 into my quadratic here. So y equals -3 squared plus 6 times -3 minus 40. And this gives us 9 minus 18 minus 40. So it'll be -49. Okay, so there's 40, 45, 50 would be right there. So -49 is going to be like roughly right there. And that's enough points. 5 points is plenty to get us the idea for the equation of the parabola like that. Okay, there's a sketch. All right, in the next video, we will explore some of these other exercises.